Okay. Hey everyone, my name is James Duduy and I work in Dr. Liu's lab in the Horticulture Science Department at North Carolina State. Today I'll be presenting Better Red Than Dead, Analysis of Tomato Genes in the Lycopene Biosynthetic Pathway. So just kind of getting into it, lycopene is a very important bioactive compound in tomatoes, or in many plants, many important fruits. And it's significant to us because it's shown to have numerous health effects, beneficial ones, such as being antioxidant, being anti-cancer. So it's important to look into. And then, so why would tomatoes produce lycopene? So as you can see on the beautiful image on the right, lycopene acts as a photoprotective compound for tomatoes against UV radiation. So UV radiation can cause oxygen to become a singlet, which is very dangerous for DNA, for cells, everything. And it can also cause DNA to change itself, which can cause cancerous effects. So lycopene can protect against that. It's actually been shown to be the most powerful carotenoid quencher of all the different carotenoids. And so what we found is that through traditional breeding, lycopene production has kind of reached its max in tomatoes anyway. And so we're looking into genetic engineering in order to kind of push it to its limit as far as it can go. So yeah, just continuing, why do we care about tomato lycopene specifically? So tomato lycopene makes up 80% of all the American diet lycopene that we intake, and most of that comes from processed tomatoes. So like pizza sauce, tomato, pasta sauce, all this kind of stuff. Very high lycopene in those kind of processed products. And also tomatoes are one of the most produced fruits the entire world around. I mean, as you can see by the little pie chart at the bottom, we are just a fraction of what's produced in the world, and it's taking up more of the world's agricultural kind of land. So it's kind of important. And then another reason is just that lycopene is one of the intermediate products between, I guess some more basic products and then later carotenoids such as like beta carotene, vitamin A, that kind of important things. So looking at the pathway, I know that I used this last time and it's very confusing. There's a lot going on, but you don't really have to focus on it. Just kind of look at the broad strokes. So lycopene, or the carotenoid biosynthetic pathway begins, or it begins where the MEP pathway ends. And the MEP pathway starts with some very rudimentary kind of compounds that, I'm sure everyone here has heard of: pyruvate, G3P, really basic stuff. So this is just kind of getting into kind of the secondary metabolites of what the tomato is producing. So the first irreversible reaction that we're looking at is geranyl-geranyl pyrophosphate synthase. So that's kind of the tipping point between the MEP pathway and then the carotenoid pathway. So after that, it's kind of destined to become lycopene at some point. So obviously, we're kind of looking at these genes to kind of see which are the most upregulated, which are in high lycopene strains, or high lycopene cultivars of tomatoes. And so we're with the basic idea that increasing the genes pre-lycopene should increase lycopene, So then following lycopene, so with lycopene at the top and then everything after is the different carotenes and everything, we have kind of a split where lycopene will either become, looks like gamma carotene or delta carotene. So those are controlled by two different enzymes, or three different enzymes, sorry, but really just two that are found in tomatoes. But this is,